concrete work at the Beverly Mercedes Place project presented many challenges to the McCarthy team. First and foremost was the problem with job site access, as the city of Beverly Hills refused to allow concrete pumping operations to take place from the city streets, in effect limiting our available setup area to a 60-foot section at the extreme northwest corner of the job site. Considering that the building footprint was approximately 150 feet wide by 450 feet long with no crane on site, placing concrete became a real challenge. At the beginning of the project, our intended method of placing the approximate 8,000 cubic yards of concrete in the subterranean parking structure was to be by way of conventional boom pumps to the maximum extent possible, tied into slick line feeding a Y setup when beyond the reach of the boom. Upon further analysis of the potential problems, we determined that dragging hose over and around the many hanging forms, as well as up and down the elevation changes, would prove to be slow and cumbersome, effectively reducing our productivity. Simply put, we needed a more efficient placement method. Working closely with D&N Concrete Pumping of Los Angeles, California, we began to investigate other possibilities, one of which utilized a concrete placer. As we became more familiar with the operation of a placer, we became convinced that this system could and would work for us. The 40-foot Crete placer was manufactured by Construction Forms and commonly referred to as a spider. The unit consists of a 5-inch diameter slick line, 20 foot long, attached to a rigid steel boom section, balanced with counterweights, capable of rotating 360 degrees on top of a 4-point base. At the end of the rigid boom section is attached another 20-foot long 5-inch slick line with a swivel connection, allowing for a total reach of approximately 40 foot from the center point when fully extended. When rotated on the base, this allows for concrete to be placed in an approximate 80-foot wide coverage area, or approximately 5,000 square feet from a single setup location. After determining that the placer would work on the project, we analyzed the pros and cons of rental versus outright purchase of the unit. Rental rates from concrete placing companies varied slightly, but the average charge was $800 per month plus $1 per yard of concrete pumped through the unit. Purchase price of the system that we selected cost approximately $12,000. Based upon the fact that we expected to pump approximately 8,000 yards through the system over a 5-month period, and that we would be able to bill the system to the owner for $800 per month plus $2 per cubic yard, the choice was clear. After consulting with McCarthy's yard boss, the purchase of the placer was approved. Since a crane was not present on the job site, the placer was moved from setup location to setup location by manual labor. This was accomplished by setting up the unit with V-groove caster wheels, then mounting the spider on top of an adjustable rail system. The rail system was designed and built for maximum flexibility so that varying setup conditions posed little, if any, problems. The rail sections consisted of sleeved, slotted steel tube sections with pinned connections, thus allowing both horizontal and vertical adjustment. In addition, we outfitted the spider with a quick coupler connection, thus eliminating problems associated with the alignment of gasketed, clamped pipe sections. To complete the system, we chose to utilize a Putzmeister 5000 trailer pump because of its ability to easily push the concrete through as much as 600 lineal feet of slick line with very little surge in the system. As an added measure of safety, we installed surge chambers in line between the pump and the spider, further reducing the surge action at the spider itself. The basic crew needed to operate the system consisted of 5 men. During operation of the system, 1 man was stationed at either the counterweights or the swivel joint, 1 man controlled the discharge, and 1 man vibrated the freshly placed mud. When the placer attained its maximum reach and required relocation to the next setup point, 2 additional men assisted in movement of the unit. The quick coupler was disconnected from the slick line. The unit was pushed to the next location. Excess slick line was removed. The quick coupler was reconnected to the slick line, and pumping resumed with a 3-man crew. This operation was consistently accomplished in approximately 4 to 5 minutes. The remaining 2 men then wash out the excess pipe, remove it from the pour area, and help relocate the adjustable rail system in preparation for the next move. This process continues until the placer is pushed onto an existing slab or out of the building boundary and the last of the concrete has been placed. Now let's take a few minutes and watch the spider in action on another McCarthy project, the John Wayne Parking Structure Project in Santa Ana, California. Here you see the slick line leaving the pump, going through a surge chamber, and here exiting out on top of a deck which has already been poured. The line runs into additional surge chambers and thrust blocks and eventually makes its way over onto the area which is currently being poured, through additional surge chambers, and finally to the placer itself, where the concrete is being deposited. Here you see the movement of the placer itself. So that concrete can be placed in another portion of the pour area. The movement of the boom, again, is very simple with 2 to 3 men operating the boom section. The unit, as you can see here, is set up on the adjustable base. Notice that the unit has very little surge action, again due to the surge chambers in line. We experienced favorable results with the spider concrete placing system. First of all, since we were able to eliminate the need to drag long hoses across the pour area, we minimized damage to rebar, sleeves, and hanging forms while actually expending less labor. This resulted in placing more concrete more efficiently. As a result, our labor placing costs averaged approximately $4.50 per cubic yard compared to our estimated $4.90 per cubic yard. Secondly, our outside pumping cost utilizing a trailer pump averaged approximately $3.50 per cubic yard, plus the $2 per cubic yard charged for the placer, totaling equipment placing costs of approximately $5.50 per cubic yard. This number compared favorably to our estimated cost of $8.80 per cubic yard. Third, since we were able to bill the system to the owner, not only did we pay for the placer itself, but we also made money on the rental. Possibly the most important aspect of all, however, was that the placer helped solve our problems related to the job site access, making the difficult job much easier. Here you see the placer being broke back, pipe sections being dropped back by the laborers, and the unit being ready to move to its next position. Four to 5 men are required to push the unit along the rails to its next setup location, while you can see the labor at the bottom of the screen relocating one of the pipe sections. Next, the rail sections are also relocated to the next area of the pour and settled alongside, waiting for the next movement of the placer. The slick line is being connected here utilizing the quick connector. And we're ready for placing concrete again. The unit is swung into position. The remaining rail sections are taken away from the pour area, and the pumping resumes. While not ideally suited to the structural conditions of the Beverly Mercedes Place job, we experienced very favorable results with the spider. In addition to helping solve our problem related to access, we experienced lower labor placing costs and equipment pumping costs. Plus, we ended up with a company-owned piece of equipment capable of producing even greater results on projects more suited for its application, such as the parking structure at John Wayne Airport. Without a doubt, the construction of the project would have been far more difficult without the use of the placer. If practical, we highly recommend its application for other McCarthy projects.